Today, we're diving into something that could completely rewrite the rules of computing. It's a speculative new idea called X8 synergy logic, and it's all about breaking free from the simple ones and zeros that have powered our digital world since, well, forever.
So let me just ask you this. Is our entire digital reality kind of trapped? For all the incredible things we do, everything, and I mean everything, boils down to just two numbers. But what if that foundation is actually a cage, you know? What if there's so much more to logic than just a simple on or off?
And this really shows you what I'm talking about. For decades, computing has been based on this hard wall. A signal is either a perfect 1, which means on, or it's a perfect 0, which means off. Anything else? Any little bit of nuance in between? Nope. It's just tossed out as noise. It's an incredibly powerful system for sure, but man, is it rigid.
So how do you get past a wall like that? Well, this new way of thinking says we don't just try to climb over it, we build brand new doors. So let's check out these new logic codes that could totally expand what computing can even do.
Okay, so this table basically lays out the whole new toolkit. We still have our old friends, 0, the ground, and 1, the pulse. But now we're adding 3 totally new kind of radical codes to the mix. -1, the inversion, x, the variable, and 8, the flow. Let's break down what each of these really means, starting with the inversion.
First up is -1, the inversion. The best way to think about this is it's the logic of opposite. You know how noise-canceling headphones work? They hear the sound coming from the outside. That's the 1. And they create a perfect mirror image sound wave. That's the -1. When those two waves meet, they cancel each other out. Boom! Silence. In computing, this could mean actively erasing interference, or even subtracting unwanted data. It's pretty wild.
Next up, we have x, the variable. Now, if normal binary is black and white, x is all the shades of gray in between. It represents potential, the unknown, even ambiguity. Instead of just asking, is the switch on or off, the x variable asks, well, how on is it? What's the signal's strength? This allows a system to think in probabilities and potential, which, is a lot more like how our own brains work.
And finally, we get to 8, the flow. This one is all about infinity and sustainability. Its whole job is to take a single pulse of energy, a single one, and transform it into a loop that can sustain itself. I mean, imagine a process that could just keep running forever without constantly needing to be recharged. That's the mind-blowing potential of the 8 state.
So a logic system that can cancel out noise, measure potential, and create infinite loops? That sounds absolutely incredible, right? But like any tech that's this powerful, this is a serious double-edged sword. There's as much danger here as there is promise.
And this visual really lays out that central conflict. On one side, you've got the dream. Unbelievably efficient systems that can actually understand nuance. But on the other side, you've got the nightmare, hardware literally tearing itself apart and security risks we can't even imagine yet. Let's look a little closer at both sides.
Let's start with the good stuff, the promise. First, you get what's called semantic richness. Computers could finally reason with nuance, not just yes or no. Second, energy efficiency. The math just works out better. It takes less power to do more complex things. And my personal favorite, this thing called the wish effect. The ability to use that -1 logic to actively subtract obstacles, letting the signal you actually want to hear come through perfectly clear. Now for the bad news, the peril. The biggest problem by far is something called hardware friction. All our current computer chips are built for ones and zeros. Trying to run this new 5-value logic on them would be like trying to play a 4K Blu-ray on an old tube TV from the 1980s. It would cause a total meltdown. Then there's just the sheer complexity of it all. And get this, there's a security risk called the observer alert. In a world that only speaks binary, a system using X8 logic would stick out like a sore thumb, a weird anomaly that would probably trigger every alarm system on the network.
Okay, enough theory. It's fascinating, but what would this kind of logic actually look like in the real world? Well, let's take a look at an amazing concept vehicle that was designed to run on it, the X8 Aero Transformer.
So get this, the Aero Transformer is meant to be the ultimate physical proof of X8 logic. It's not just a car, it's a mobile computer, and it uses those different logic states, 1, X, and 8, to literally change its physical shape and what it can do. This is where the abstract ideas get very, very real.
So here's how it would work. In state 1, or ground mode, it's just a normal car driving around. But when the transformation gets triggered, it shifts into state X, that state of pure potential.
The wings deploy, the wheels start to reorient, and energy just builds up. Then it hits state 8, flight mode. It enters what's called an infinite surge, using its thrusters to get into the air and just stay there. The logic is directly controlling the physics of the vehicle. It's incredible.
A transforming car is one thing. That's super cool. But the implications of this logic go so much deeper. I mean, if you can use a -1 to cancel out a sound wave, what else can you cancel out? And that leads us to a really profound question. Could this be a way to actually reset reality itself?
And this is where it gets really, really mind-bending. The source material makes a crucial point here. This isn't about hopping in a DeLorean and going back to the past. It's a reset of intent. It's about using this logic to peel back the digital layers we've built on top of an original state.
This visual just nails the difference. A normal computer reset, a zero reset, is like taking a blackboard and wiping it clean. The information is just gone, deletion. But a -1 reset, that's an inversion. It's like watching a video of a glass shattering, but playing it backwards. The pieces don't disappear, they fly back together to make the glass whole again. It's not deletion, it's restoration.
And that brings us right to our final thought. The power to undo decay, to subtract problems, to restore things to how they were originally. That's so much bigger than just building faster computers. It challenges how we think about information, reality, maybe even time itself. So the question we're all left with is a pretty big one. If we can actually undo our digital world, what kind of world are we going to choose to build instead?